So your MCS2 spring 2019. Okay, good. We want to define a member recursive function. Although the built-in member function is available in LISP, but since we want to understand the recursive programming, therefore we want to define our own member recursive function. Member recursive function will take two arguments and will insert the first argument from the second list. If it is present, as you can see in the first call, the 10 is present in the list, it will simply return true. Okay, it will simply return T as a true. And if the element it is searching is not present in the list, it will return false. And as a false, in list only nil will be returned. Okay, we want to define this function. In list, we know that function is defined using define command. After the define command, we should be writing the name of the function. It is the member recursive. We can write the full name, complete name, or we can write it in short way, member recursive. Okay. The first important thing, the basic thing, is the number of arguments. Few of you have made that mistake. They have written only one argument in the argument list. It is obvious, it is clear. In both these calls, you can see the function is getting two arguments. No matter they are atoms or they are lists, they will be considered as argument. The first argument can be anything, okay? It can be symbol, it can itself, it can be a list, okay? But whatever it is the first argument, it is the second argument in both these calls. So, in the argument list, you must be writing the two symbols, two variables, okay? And you can name them as X, Y, A, B, whatever you want, okay? But the important thing in list syntax is that you should be writing the variable names as I'm writing E and X with the space. You should not be writing comma. In other languages like C++, in the argument list we put comma for separation of variables. And in the other languages we also put the data types. But in list, memory management is done by the LISP interpreter itself. We don't need to mention the data type, and both these arguments will be separated by the space, not by the comma. Space is must. Space is must. Okay. Now, after the function header line, we want to define a recursive function, so it will require a condition statement. And we want to use the count statement as condition statement. Count is a built-in statement. Now in this function, in this example, you should identify that how many exit clauses are there. What are the different scenarios? What are different scenarios? The first scenario is that when that element will match with the car of X. The first element, we will found the element, we will stop. Okay? That is the one scenario. When the element is found, we should stop. We don't need to make the recursive call. Okay? That is the one scenario. That is the one condition. The other condition is that when the element is not found and we have traversed, we have searched the complete list and the complete list is consumed. We have not found the element. In that case, our first argument is E, second argument is X. Our second argument X has been consumed. It is an empty list. In that case, we should also stop. In the second example, our argument is X. When recursive call will be made on the reduced cutter of X, gradually it will be an empty list. And when it will be an empty list, what should we return? We should return nil. That element is not found. We should return nil. Okay? But when it is found, when it is matching with car of X, then we should return T. So, besides the default class of making a recursive call on the reduced list, above the default class, now in this example, we have two different scenarios. There are two stopping conditions. Okay? We should be encoding both these conditions separately. Both these conditions separately. It is up to you. You can encode any of the conditions first. But in order to follow the same pattern as we have done in previous example, I am checking the empty condition first. When our list X is reduced to an empty list, null function will return true and we should return nil. Okay? This is the one stopping condition. Okay, this is one exit class. The second exit class is that we should be comparing car of X, first element of X with E. This is the condition. This is the condition. When it is equal, we don't need to traverse the remaining elements. Okay, we should stop. The element is found. Okay, we are not counting the number of occurrences. If we would have been counting the number of occurrences, then obviously we should have continued. But we are not counting the number of occurrences. We are just finding out only at least one occurrence of the given element, and we should return t. Therefore, in the second class, which is also an exit class, we are returning t. T will be evaluated to itself. We are not doing anything else. Okay. The important part, this mistake which most of you have made is that you have mixed up this class with the default class and with recursive call should be made. Okay. Now you don't need to make the recursive call in this case. We should stop. Okay. Therefore, the parenthesis of this class, the second class, has been closed over here. Now we should make the write the default class, and in the default class, control of execution will only reach when the list has some elements to be searched. Okay. And we have not yet found the element. Means both these conditions are false. Both these conditions are false. Control will go to the default class, and in the default class, we don't need to maintain the result. We can simply call the member recursive on getter of x. Member recursive call, this is then part, and this is default class. Over here can't close, over here define close. Now it is okay?
Yes, sir.
Or is there any mistake? What is the mistake? This is the check we are performing to check whether the curve x is equal to the given element E. Okay, this is the check which will be comparing every given element with E, our required element. What other mistake we have in this code? Can anyone of you tell me? Regarding the number of arguments, how many arguments the function is getting? Yes, in the recursive call, we have made the mistake. We are mistakenly passing one argument. You can see it? Okay, we should be passing two arguments. Whether we are calling the member recursive on top level, or whether we are calling the member recursive in its own definition. We must be passing two arguments. These two arguments are compulsory. Okay, none of these arguments are optional. So, the first argument was missed. We should correct our code. The first argument E should be passed to it as it is. Okay. Now it is understandable?
Yes, sir.
Okay. Now we should be tracing. I mean, we can trace both these calls one by one. Okay. Now, in order to fully understand the definition of the recursive definition of member recursive function, we want to trace both these calls. Okay. In the first call, first argument, before applying the function, 10 will be evaluated to itself and 10 will be passed to E. Okay, 10 will be passed to E. The second argument code will be removed. The less 20, 10, 30 will be passed to second argument x. Okay, control will go to the definition of the function. The first check is null x. X is an empty list? No. Control will go to the second condition. Condition of the second class. Car of x is equal to E. What is car of x? 20. 20 is equal to 10?
No.
No. When the condition is false, control will not go to that part. Control will go to the next class. And the next class is the default class. And in the default class, we are calling the member recursive function again on the reduced list. 10 and cutter of x. If we take cutter of x, then it will be 10 and 30. Is it understandable?
Yes.
Okay. Now, in this function call, again the call will match with the header line of the function definition, the first argument. 10 will be passed to E, the second argument. 10 and 30 will be passed to x. Now, with these values of E and x, the code of the function will be executed. First class condition, x is an empty list? No. Car of E is equal, car of x is equal to E? Yes, it is 10 and E is also 10. So both these values are matching, equal function will return true, and the control will go to the then part of the second class. It will not go to the recursive call or default class. It will go to then part, and you can see T is returning. That member recursive will return in the default class of the upper outer recursive function call. Okay, and that outer function will return true. I hope it is understandable. Okay, now we want to trace the second example. Again, 50 is being passed to E and 10 and 20, 10, 30 list is being passed to X. Okay. First condition, X is an empty list? No. Equal E car of X? No. It is 20, it is 50. They are not equal. Control code is the default class. And in the default class, we are calling member recursive. Again on E, 50 is being passed to it as it is. And on the cutter of X, 10 and 30. Now E is 50 and X. For this member recursive, X is a reduced list. X is an empty list? No. Equal E car of X? No. Control again go to the default class. Member recursive 50, 30 with the list. E is 50, the same value, but X is the reduced value. Okay. Control go to the count statement again. Null X is an empty list? No. Equal E car of X? Car of X is 30, E is 50, they are not equal. So the second class condition is also false. Control will go to the default class, and in the default class we are calling the function again. We are making recursive call on E as it is and cutter of X. 30 will be removed when we take cutter. So this command is being executed. Whatever it will return, the function definition, the function will return the same thing. So in this case, E is 50, X is an empty list. Now with these values of E and X, we will be tracing the function definition. The first condition will be checked. X is an empty list. Null function will return true on empty list. So now in this case, control of execution will simply return nil from the first class. It will not go to the remaining classes. So this will return nil. And this then will be returned in the default class of this function. It will also return nil. It will also return nil. And you can see at the top level, nil has been returned because the element E is not present in the given list X. I hope it was understandable.
Yes, sir.
Now you may note it down quickly, then we shall move to the next example.